Hello and welcome to A-Level Math. This is the fourth video in the series Straight Lines. We have covered almost everything that is required for building up the basics and fundamentals of straight lines. In this video, we are going to discuss about the distance from a point to a given straight line and the distance between two parallel lines. So this video assumes that you have already seen all of my previous video. If you haven't, then please click on the I button above. So let's get started. First of all, the distance of a point from a line. So what do we mean by that? I mean that it's obvious. Suppose I have some line. Suppose that the equation of the line is ax plus by plus c is equal to 0. It could be like 3x minus 2y plus 8 is equal to 0 or anything. A, b and c can be any real numbers, positive or negative. So if I take any straight line of this form and suppose I take a particular point, suppose let's call it alpha comma beta. So suppose that this point is alpha comma beta and I want to find out the perpendicular distance. Remember that distance has always meant perpendicular distance. So if I want to find out the perpendicular distance of this point alpha comma beta from this line ax plus by plus c is equal to 0, then what is actually the distance? So there is a formula for it and I want you to remember the formula, and of course please go through the proof of this formula in your textbook. You can find it in any standard textbook. I will just give you the formula, but I strongly insist you to look at the proof. It will help you build up your theorems, the understanding of theorems, as well as it will help you retain these formulas in mind for a longer term. So the formula is the distance. Suppose the distance is d, then the distance is given by modulus of a alpha plus b beta plus c divided by root over a square plus b square. Okay, so the formula says something like this. Suppose that I have a line 5x plus 2y minus 8 is equal to 0, and I want to find out the distance of this line from this point, suppose minus 3 comma 2. So the formula says that all you need to do is just put down these alpha and beta in place of x and y. So that is why I get a alpha plus b beta plus c, because I have just replaced this x and y with alpha and beta. So it gives me a alpha plus b beta plus c is equal to 0. Remember that you have to always first of all write down the line in this form. What I mean is that suppose if the line, instead of given to you like this, is given to you like this, 5x plus 2y is equal to 8, then you have to first of all make it 5x plus 2y minus 8 is equal to 0. Always remember that this is the standard form of the equation of a line, and you always have to reduce any equation in this general or standard form. Then what you need to do, you need to replace x and y with alpha and beta. C will remain as it is, so a alpha plus b beta plus c divided by these coefficients. Remember, it's a very common mistake that students do, that instead of writing down a square plus b square, they put down these minus 3 and 2. So they do minus 3 square plus 2 square, but it is incorrect. What you have to do is put down these coefficients because they are a and b. So what are the coefficients of a and b? You have to put them down here. It is not alpha and beta. Okay, so this is one common mistake that you are supposed to do. I'm warning you from the very beginning. So please make sure that you are putting down a and b and not alpha and beta over here. Okay, let's take one example to understand. So we have to find out the distance of this point from this line. So first of all, you have to verify that it is already given in the standard form. That means it's given the form ax plus by plus c is equal to 0. Everything is on the left side and 0 is only left on the right hand side. You have to write it down in this form. And then you can find out the distance d to be equal to modulus of 3 times 4. Remember that you have to replace x and y with these points. So 3 times 4 minus 4 times 1 plus 12 mod close divided by root over what? 4 square plus 1 square? No, idiot. It is 3 square minus plus minus 4 the squared. 3 squared plus minus 4 the squared. So remember that in the denominator always you have to put down 3 and minus 4 a and b instead of 4 and 1. Remember, you should not be doing the mistake. Now let's simplify this. So 12 minus 4 plus 12 divided by root over 9 plus 16 is equal to 24 minus 4 gives us mod of 20 divided by root 25. So now mod of 20 is just 20 because modulus makes negative as positive but doesn't change positive values. So 20 by root 25 is 5. So this gives me 4 units as my final answer. Why units? Because we are calculating a distance, and distance must have some units: centimeter, meter, inches, feet, whatever it is. So we always don't forget to mention the units. Find the length of the perpendicular from the origin to this line. So now we have the point to be 0, 0. So the distance can be found out just by applying the same formula. Just to replace x and y with 0 and 0 in this equation. So we have 4 into 0 plus 3 into 0 minus 2 divided by root over 4 square plus 3 square, which is equal to mod of minus 2 divided by root over 16 plus 9, which is equal to 2 by root 25. Why 2? Because modulus of minus 2 will make this as positive 2. So 2 by root 25, which is 2 by 5 units, is my final answer. What are the points on the y-axis whose perpendicular distance from the line this is 3 units? So it is asking you to find out a particular point. So let's quickly draw the x and the y-axis. Our line is, suppose our line is this. It may be upward rising. Forgive me if I'm making the equation wrong, but it's all okay. Let's always be technically correct. Okay, so 4x minus 3y minus 12 is equal to 0. So let's actually figure out how this line should look like. I don't want you to follow my path and be incorrect. That's why I'm doing this much of extra labor, even though this is not actually required. So 4x minus 3y is equal to 12. You can write this equation like this and then divide everything by 12. So 4x by 12 minus 3y by 12 is equal to 12 by 12. So we get x by 3 minus y by 4 is equal to 1. So I get the x-intercept to be equal to 3, 0. So this is my x-intercept. Remember where we are getting this from? We are getting this from the intercept form. I told you I'll be using the things that I've taught you in the previous video. So this is the x-intercept 3, 0, and the y-intercept will be minus 4 because we have to adjust this minus over here. So we'll be getting the point somewhere over here. The point is 0, minus 4. So this is how our equation of the line will look like. And now we are asked to find out a point on the y-axis. We have to find out a point on the y-axis. So suppose the point lies here and we want it to be such that its perpendicular distance is 3 units. We want this distance, we want it to be 3 units. Okay, so because the line lies on the y-axis, so that is why it could be of the form, suppose 0, y, because any point on the y-axis should have the point to be of the form 0, 3, 0, 5, 0, minus 2, anything. So we take the point to be 0, y. All we need to do is just find out the value of y and we are done. Okay, so what is the equation of this line? 4x minus 3y minus 12 is equal to 0. Now what we have to do, we have to find out the distance of this point from this line, and we already know it, so we will be getting an equation. So what is the equation? First of all, what we need to do, we need to replace the x and y with 0 and y. So if you don't want this to be y because y is already in the question, so you can take it to be k as well. So let's assume that the point is actually 0, k. So let's not confuse ourselves with x and y. That is why I'm taking it as to be k instead of y. So what is the distance of this point 0, k from this line? So it is given by 4 times 0 inside the mod minus 3 times k minus 12 divided by root over 4 square plus minus 3 square, and this is given to be 3 units. Now all we need to do is just simplify and solve this equation. So let's see what we get. We get 0 minus 3k minus 12 inside mod divided by, again, root over 25. It will turn out to be 5. You can verify, we have been doing this in the previous two questions, the same thing, is equal to 3. So we have modulus of minus 3k minus 12 is equal to 15. Okay, let me clean up the things. Minus 3k minus 12. So we have finally modulus of minus 3k minus 12 is equal to 15. So remember what I told you, that in the previous videos I have always told you that whenever you want to replace the modulus, all you need to do is just write down plus and minus on the right hand side, because even if it is plus 15, it will give you the output as 15, and even if it is minus 15, so it will still give you the output to be 15, because that is what modulus does. It always throws the positive output. So this means that the inside part could be even plus 15 or it could be minus 15. So that is why minus 3k minus 12, which is the inside part, could be either plus 15 or minus 15. So we take the plus 15 first. Minus 3k minus 12 is equal to 15. So we have minus 3k is equal to 15 plus 7, 12 is equal to 27. So we get k is equal to minus 9. If we take it to be minus 15, then we get minus 3k is equal to minus 3, and we get k is equal to 1. So remember what we took our k to be. Our k was the point which was given by actually 0 comma k. So there are 2 points on the y-axis which actually satisfies this property, that it has 3 units distance from this line. So the answers are 0 comma minus 9, and the other point is 0 comma 1. These are the 2 points which both have which are both at a distance of 3 units from this line. So we have 2 answers. Okay, let's move on to the next problem. If P is the length of the perpendicular from the origin to the line whose intercepts on the axis are A and B, then show that something holds. So what the question says is that there is a particular line whose intercepts are A and B on the axis. Suppose that this is our line and the x intercept is A units. So this is A comma 0, and the y intercept is B units. So this is 0 comma B. So what can we say from the intercept form? That the required equation of our line will be x by a plus y by b is equal to 1, because this is what the intercept form says. If we are having a line which makes x intercept equal to a units and y intercept equal to b units, then the equation of the line is x by a plus y by b is equal to 1. So this is the equation of the line, and this says that this line has a distance of p units if p be the length of the perpendicular from the origin. So if we drop a perpendicular from the origin to this line, then this length is p units. Okay, that means this is effectively the distance of this point, this origin, from this line. All right, this is what the question actually says, that the distance of origin to this line is p units. So we already know how to calculate the distance of a point from a line. So first of all, we have to write this equation in the standard form. So we can write it as bx plus ay is equal to ab. This is the standard form of the line. And now we have to find out its distance from the origin. So we can find out the distance d to be b times 0 plus a times 0, and we have to take this ab on the other side. Minus ab is equal to 0. So we have minus ab divided by root over b square plus a square. Remember the coefficients of x and y. So this is the distance of the origin to this line, and we are given that this distance is actually p units. So I can write this equation, and now I have to simplify this to somehow reach this. So let's see what we can do. We have p is equal to b and a will be eliminated, minus ab divided by root over a square plus b squared. Then we can actually square both the sides. So what we have upon squaring is p square is equal to a square b square, because if you square on modulus, it just eats up the modulus. Suppose that I have -3 inside mod and then square, or even if suppose I have mod of 3 whole square, both of these will give me an output of 9, because it doesn't matter whether in any way the output has to be 3 for this case, and then squaring it up will give you 9. And similarly for this case, the output for mod 3 is 3 and you square it up to get 9. So it doesn't matter what you have inside. If doesn't matter whether you have positive number or negative number, you just square it considering to be the positive number only. So we have a square b square divided by a squared plus b squared. All right, now what we can do, we can reciprocal on both the sides. So we have 1 by p square is equal to a squared plus b squared divided by a square b square. And now we can split it up, so I'll make some space for myself. So what we have is 1 by p square is equal to a squared plus b squared by a squared b squared, and then we can split it up into two parts. So we have 1 by b square is equal to a squared by a squared b squared plus b squared by a squared b squared. A square cancels out, we have 1 by b squared. B square cancels out, so we have 1 by a squared, and this is what was required to be proved. We are done. Next question. If P1 and P2 are the lengths of the perpendiculars from the origin to these two lines, so it says that you take this first line, this is the first line that you have to take, and this is the second line that you have to take. The perpendicular distance from the origin on the first line is P1 units, and the perpendicular distance from the origin on the second line, this is P2 units. This is what the question says. If this is the case, then you have to prove that this thing will hold. Okay, so what do we do? First of all, consider the first equation. So we are given x sec theta plus y cosec theta is equal to a. This is the first line. So I have to take this a on the other side because I want it to be in the standard form. And I have to find out its distance from origin 0, 0. So let's find it out. The distance, which is actually P1. So I can write down P1 instead of D. So the P1 is equal to 0 times sec theta plus 0 times cosec theta. Remember that we have to replace x and y with 0 and 0, n minus a whole inside mod divided by root over sec squared theta plus cosec squared theta, the coefficients of x and y. So what do we get as P1 to be equal to? Mod of minus a or a, whatever you may want to write it down as, mod of a divided by root over sec squared theta plus cosec squared theta. This is what is P1. Now, similarly, if you want to find out P2, we have 0 times cos theta minus 0 times sin theta minus a cos 2 theta mod closed is equal to, whole divided by root over cos squared theta minus plus minus sine theta the whole squared, or we can just write it down as plus sine squared theta. So what I did was just find out the distance of this line from origin. So just putting down 0 and 0 in place of x and y, and minus a cos 2 theta remains as it is, and then divide by cos squared theta plus sine squared theta. Okay, so this gives me mod a cos 2 theta divided by 1, because sine square theta plus cos square theta is actually equal to 1. And then we need to find out how to get this final result as the question is asking. So if you see, we have to actually eliminate theta. For that, what we need to do is, let's take up the first equation in terms of this P1. So what is this? Let me write down the facts again. So So these are the facts that we have. P1 is mod A by root over sec square theta plus cos x square theta, and P2 is mod A cos 2 theta. Now let's just try to figure out what is LHS. LHS is 4P1 square plus P2 square, and let's just figure it out what it turns out to be. So what is P1 square? P1 square is A square. Remember I told you that on squaring modulus you can eat up the modulus. So A square by sec squared theta plus cos x squared theta, and what is it asking is to find out 4p1 squared, so we just multiply with 4 on both the sides. And what is p2 squared? P2 squared is a squared cos squared 2 theta. Now let's just see what do we get on adding these stuffs. So we have 4p1 square plus p2 square. We have to just replace these values and figure out whether it's actually on simplification giving out a square or not. If it does, then we are done. So putting down values, 4a squared by sec squared theta plus cos squared theta plus a squared cos squared 2 theta. So we can take a squared common, or we can take 4. No, okay. So what we have is 4 divided by sec squared theta plus cosec squared theta. I'm sorry, it was cosec. So cosec squared theta plus cos squared 2 theta. So I get a square, then 4. If I multiply or just reciprocal it, make the sec squared theta as 1 by cos squared theta, and this cosec squared theta as 1 by sine squared theta. And then if I take the LCM, then what I'll be getting is 4 sine squared theta cos squared theta divided by cos squared theta plus sine squared theta. If you take the LCM in here, so if this part you take the LCM, then you'll be having cos squared theta sine squared theta, which will actually go up, and in the numerator you'll be having sine squared theta plus cos squared theta. So, and then cos squared 2 theta left out. So cos squared theta plus sine squared theta, this part is actually 1, so I can remove this and actually remove this entire part. So finally we are left with 4 sine squared theta cos squared theta. I can write this as 2 sine theta cos theta the whole squared, right? Because it is 4 sine squared theta cos squared theta, so I can write this as 2 sine theta cos theta the whole squared. Now what is 2 sine theta cos theta? 2 sine theta cos theta is sine 2 theta from multiple angles, remember? So this is sine 2 theta, and sine 2 theta the whole squared is actually sine squared 2 theta. I'm sorry for doing it this way, but I seriously don't have enough space. So sine squared 2 theta plus cos squared 2 theta, which actually give me 1. So I'm having a square times 1, which is a square. And this is what was required to be proved. We had to prove that for p1 squared plus p2 squared is actually a square. We are done. Next question. Find the coordinates of a point on the line this, whose distance from this line is root 5. So this is a similar question to what we have done previously, but in that we are given that the point lies on the y-axis. Here we want a point to lie on this line whose distance from this line is root 5 units. So what this question asks you is to find out a point on this line whose distance from this line is root 5. So let's assume that the point is alpha comma beta. We have to find out the values of alpha and beta. So there are two things that we have in hand. First of all, that alpha comma beta lies on this line, so it must satisfy its equation. So that means we have the first equation to be alpha plus beta plus 3 is equal to 0. This is our first equation, all right? And secondly, we are given that the distance of this point from this line is root 5. So what is the distance? Distance is root 5, and the formula is alpha plus 2 beta plus 2 inside modulus divided by root over, the coefficient of x is 1 over here, so 1 square plus 2 square. So we get root 5 is equal to mod alpha plus 2 beta plus 2 divided by root 5. I can cross multiply and I get alpha plus 2 beta plus 2 inside modulus is equal to root 5 times root 5, which is actually 5. So we have two possibilities. The first possibility is alpha. Okay, I'll write this again along with this equation. So I'll be writing them down again. Let me make up a bit of space. Plus 2 beta plus 2. So we have alpha plus 2 beta plus 2 modulus is equal to 5. So that means either alpha plus 2 beta plus 2 is either plus 5, or alpha plus 2 beta plus 2 is minus 5. Remember, whenever we get rid of these modulus, we have to supply plus or minus on the other side. And the first equation was alpha plus beta plus 3 is equal to 0 because the point lies on this line. So if I take this equation and this equation, I solve them simultaneously, I get some values for alpha and beta. There are two equations, I can solve them to find out the values of alpha and beta. And if I take this equation and this equation, I'll be getting some another pair of alpha and beta. So I leave this to you as an exercise and find out these two pairs of points. So I'll be having 2 points, first one from solving this and this, and second one from solving this and this. So find out all these 2 points and just let me know in the comment section. Now another concept. The concept is the distance between two parallel lines. What we have considered so far is the distance of a point from a straight line. But suppose if I give you two parallel lines, this line and this line, suppose that these two lines are parallel, then at any given instance, the distance between these two parallel lines is going to be constant, right? So I'm interested in finding out this distance. Remember that the distance between two concurrent lines, I mean two intersecting lines, I'm sorry, that the distance between two intersecting lines is never important because this distance keeps on changing at different instances and it actually becomes 0 at some point as well. This is known as the point of intersection. So we are not interested in the distance between two intersecting lines because that's non-constant at different instances, but this distance between parallel lines is actually important because it remains constant. So how do we find it? Suppose that I give you two lines. The first line is ax plus by plus c1 is equal to 0, and the second line is ax plus by plus c2 is equal to 0. Now why I'm taking them like this, because remember I told you that if two lines are parallel, then their x and y coefficients are always similar. If this is a, then this will also be a, and if this is b, then the y coefficient will also be b for the second equation. All they differ by is this constant. So you change this constant, you'll be getting some other line which is of course parallel to the first line. So suppose that I take these two lines as the point of consideration. So these are the two parallel lines. Ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. Then the distance between these two lines is given by mod of c2 minus c1 divided by root over a square plus b square. So this part remains almost the same. It is the coefficient of x and y. This distance changes. Okay, so instead of like in the previous cases where we are finding the distance of a point from the line, we had a alpha plus b beta plus c. Now we have just the difference of these two constants. Okay, so let's apply this formula. Find the distance between the parallel lines 15x plus 8y minus 34 is equal to 0 and 15x plus 8y plus 31 is equal to 0. So you see that of course these two coefficients are equal, 15, 8 and 15 and 8. All they differ by is this constant. So the distance between these two lines, suppose D, is given by mod of C2 minus C1. You can take any one. If you can consider this as C1 and this as C2, or you can consider this as C1 and this as C2. Doesn't matter. You can go anyway. So let's consider this as C2 and this as C1. So I'll be having 31 minus 34 because C2 minus C1. So 31 minus 34 divided by root over 15 squared plus 8 squared. I leave this to you as an exercise to find out its value. Okay, but don't be as lazy as me. Okay, you have to solve all these things. And hopefully the last question for today. Find the equation of the line midway between the parallel lines 9x plus 6y minus 7 and 3x plus 2y plus 6 is equal to 0. So we have two parallel lines. Now we will say, sir, you said that always these coefficients will match, but in this case they are not matching. So how come they are parallel? So what I want you to notice that if you multiply each of these terms by 3, suppose if we multiply each of these terms by 3, so we get 9x plus 6y plus 18 is equal to 0. So this line is actually this line, they are both equal, no problem. And now you notice both of these coefficients, 9x plus 6y and 9x plus 6y, they actually turn out to be the same. So they are actually parallel, they're just hidden. We have to find out the line midway between these two parallel lines. So suppose we are given these two lines, 9x plus 6y minus 7 is equal to 0, and another straight line is given to be 9x plus 6y, I'm sorry I missed the y here, 9x plus 6y plus 18 is equal to 0. We have to find out the line that is midway between these two parallel lines. So let me change the color, I'll use the black one. So we have to find out the equation of, suppose, this line, which is midway between these two parallel lines. So how do we do that? So first of all, you have to notice that because these three lines are parallel, then all of these slopes, the slopes of all these three lines are actually going to be same. So what is the slope of this line? You can find out anyway. You can go find out the slope of any of these lines. You can find out the slope of this or this. They will be same because they're parallel. So what is the slope of the line? Let's use the second one. 3x plus 2y plus 6 is equal to 0. So we have 2y is equal to minus 3x minus 6. So we have y is equal to minus 3 by 2 x minus 6 by 2. So y is equal to minus 3 by 2 x minus 3. So this is the slope. Minus 3 by 2 is the slope of our parallel lines. All of these lines are parallel. So all of these lines have slope equal to minus 3 by 2. So in particular, my line, which I am interested in, is also having a slope of minus 3 by 2. So let me assume that the equation of my line is y is equal to mx plus c, where my line is already having a slope of minus 3 by 2. I know all I need to find out is just the constant c. If I can find out this constant, then I'm done. So let me write this equation in the standard form, because we always deal with standard forms while dealing with distances. So we have 2y is equal to minus 3x plus 2c. So we have 3x plus 2y minus 2c is equal to 0. So this is the standard form of my line. Okay, so this is my third line. 3x plus 2y minus 2c is equal to 0. Okay, let me erase some of these things. Okay, so these are the facts that we have. In fact, I was an idiot to do all of these stuff. We already had known that this required line should be having these coefficients to be 3 and 2. So we could have just taken any constant, k or k1, k2, any constant over here. So that would have given us the same result. So okay, let's proceed in that way only. We were given these two lines and we had to find out the third line that is midway between these two lines. So we already know that the x and the y coefficient should be same. So let's take them to be, let's take our required line to be 9x plus 6y plus k is equal to 0. Let this be our required line. No, doesn't matter whether it is 2c or what, the values of k or c will adjust automatically depending upon the question. So let's assume that our required line is this. So whatever we did previously, you can forget about it, totally forget about it. So now what we know is that this line is midway. That means this distance is actually equal to this distance. So what is this first distance? So this distance is k minus minus 7, just k plus 7 mod divided by root over 9 square plus 6 square, which should be equal to this distance. So what is this distance? This distance is actually mod k minus 18 divided by root over 9 squared plus 6 squared. All right, so now this entire part cancels out, and what we have is mod of k plus 7 is actually equal to mod of k minus 18. Why is this guy blinking? I don't know. and I'm not able to erase things. Okay, so this is the last question. Let's quickly wind it up. So we have k plus 7 mod is actually k minus 18 mod. So we can replace both of these mods by plus or minus k minus 18. So we cannot have k plus 7 to be equal to plus k minus 18, because in that case we'll be having 7 is equal to 18, which is very, very odd. So what we have is actually k plus 7 is equal to minus k plus 18. You can take k on the other side. We have 2k is equal to 18 minus 7, which is 11. So we get k is equal to 11 by 2. So our final required equation is 9x plus 6y plus 11 by 2 is equal to 0. You can multiply all of these numbers by 2 to simplify. So we have 18x plus 12y plus 11 is equal to 0. This is our required answer. And that's it. We reached the end of this video tutorial, and hopefully I'll be having one more final part on straight lines to cover up even harder problems. So let's see what we have in the days to come. Till then, stay tuned with A-Level Maths. Thanks a lot. Study hard and study smart. Bye-bye.